H.C. Verma, Wave Motion and Waves on a String, Question 57. Let us look at the setup. A heavy string is fixed at one end to a movable support, like a cart on wheels. The other end is tied to a light thread which passes over a fixed pulley. A weight hangs from the thread, producing tension in the string. The joint between the heavy string and the light thread is 10 centimeters from the pulley. The key physics here is the boundary conditions. The heavy string is fixed at the support end, that's a node. At the other end, the junction with the light thread acts as a free end because the light thread has negligible mass. So the heavy string has one fixed end and one free end. Here is the fundamental mode, a quarter wavelength fits in the string length. Now the movable support is pushed to the right by 10 centimeters. This places the joint exactly on the pulley. The pulley is a fixed point, so now both ends of the heavy string are fixed, giving us two nodes. Watch the fundamental mode, now a half wavelength fits in the same length. Here is the question. A heavy string is tied at one end to a movable support and to a light thread at the other end. The thread goes over a fixed pulley and supports a weight. The lowest resonance frequency is 120 Hz. If the support is pushed right by 10 centimeters, so the joint reaches the pulley, find the new minimum resonance frequency. The key concept is boundary conditions for standing waves. A fixed end is always a node. A free end is always an antinode. For a fixed free string, the fundamental has a quarter wavelength fitting in the length, giving frequency V over 4 liters. For a fixed string, the fundamental has a half wavelength, giving V over 2 liters, exactly double the fixed free case. Step 1. Initially, the heavy string has length L, one end is fixed at the support, a node. The other end meets the light thread. Since the thread has negligible mass, this acts as a free end, an antinode. For a fixed free string, the fundamental frequency is V over 4 liters. We are told this equals 120 Hz. Step 2. The support is pushed right by 10 centimeters, exactly the distance from the joint to the pulley. So the joint now sits on the pulley. The string length remains L, the support moved forward by the same amount that the thread shortened. Now both ends are fixed, the support is a node and the pulley is also a node. For a fixed string, the fundamental frequency is V over 2 liters. Step 3. Substituting V equals 480 liters into the new formula. F1 prime equals 480 liters over 2 liters. The L cancels, and we get 240 Hz. The minimum resonance frequency doubles from 120 to 240 Hz. The correct answer is 240 Hz. The frequency exactly doubles because the boundary condition changes from fixed free to fixed, while the string length and wave speed remain the same. Here are some important tips. Tip 1. A light or massless string junction acts as a free end for the heavier string, always an antinode. Tip 2. Fixed free fundamental is V over 4 liters while fixed fundamental is V over 2 liters, the ratio is exactly 2. Tip 3. When the string length does not change, the frequency change comes purely from the boundary condition change. Tip 4. In problems with pulleys, identify whether each end is a node or antinode before writing the frequency formula. Like and subscribe for more H.C. Verma solutions at MAGPIEHUB. See you in the next video.